Mike. Thank you for coming here today. My name is Bill Zajac. I'm a sales engineer with Teridion, and as soon as you have sales in your title, no one pays attention to you, so that's why I'm at the end of the talk, so at least we have some sort of credibility right now on how this stuff works. What I'm going to be going over today is more so just a day in the life of a customer. So we normally do a demo, we normally show them something like the upload that you saw in the first part of the presentation, and then customers say, how do we get onto the Teridion network? What's required from the data that we need to gather, and how do they actually implement that from their side? So ultimately, when we first start off with the customer, they have their application server set up like this. They have some sort of domain name that ultimately has some sort of IP. In order to get to that IP, you have some sort of DNS resolution that happens. This is how the internet works. This is how most major applications work. But in a more complex, more heavily load balance type architecture, there's normally some sort of load balancer domain in the middle. This is what we suggest all of our organizations actually do. So as opposed to having your strictly public-facing domain going directly to your server IP, you have some sort of load balancer domain that's in the middle of it, and then that will ultimately go to the actual server IP as well. This is going to come into play a little bit later so we can make sure that the Teridion network, if there ever is any issues, that they need to go over to public internet for whatever reason, they ultimately have the decision to do that, as well as they can make their own management or mappings with their IPs in the back end without ever having to talk to us as well. So when the Teridion network's actually enabled, what that customer, all they have to do, as opposed to CNAMing over to that load balancer domain, they CNAME over to our Teridion optimized domain, and then that will put them on the network, and then ultimately it'll get dropped off to where it needs to end up as well. From an information required perspective, there's about 5 or 6 simple questions that we ask any customer. What's the domain you want accelerated? What's the actual load balancer domain that we need? If they don't have that, we basically ask them just to make a duplicate one that we're going to point to. What's their expected traffic? What's the number of ports that they're running on within their network? We're strictly a network-based layer 2 and layer 3 technology. So all we really need to know is it TCP or UDP? That's about it. And then for some sample file testing that we'll do with Catchpoint, we also require that just a simple 5 meg file that we can use, that we can constantly test not only the Teridion network but the public internet, so we can get those nice 20x numbers to show them that the actual performance is working.
Sorry, what is this required for? You might have said this, but is this required for initial setup of a customer?
Yep. So this is the questions that we ask our customers to create the VBN for them for that specific application.
Okay. So it's a one-time thing, basically.
Yep. One-time thing.
Okay.
Yep. So let's build a VBN. So first and foremost, what I want to do is I'm going to go just into my terminal real quick. I'll make sure that everyone can see it. Right? You guys can read it? Yeah.
Yeah, I can read that clearly.
All right.
All right, there we go.
So what I'm in right now is this is just a DigitalOcean VM that's hosted, or sorry, this is a DigitalOcean VM that's in India right now. What I'm going to be standing up is just a simple speed test server. Then I'm going to hit that locally from my browser, show you what type of speed I'm getting at currently. Then I'm going to enable a Teridion network on that just to showcase what that can ultimately do in the long run. So, and I got a nice little notepad, and let me set this up the way that I had it originally. So some quick yum installs for getting my HTTP server on here. We are going to turn him on. We're going to put on PHP. Oops. Okay, and then just do a service real quick. I can spell service. Okay, and so now if I actually go to the IP that I want to go take a look at, I should see that, lo and behold, this 139 guy is now just an Apache server. Nothing great. But I'm going to now just do a quick speed test guy on this guy. So I already have him. I'm going to move him into my directory. Okay. And so now this guy should be a speed test. Nope, he's not. Now he's going to be a speed test. Okay. So now I'm hitting this guy locally from my desktop within California. He's running in India. I'm just going to go ahead and click begin test over this Wi-Fi, and we'll see what type of speed that we get. So it might take a second of him for actually to connect. And going over to India, this is pretty much our expectations of how the internet's going to work. About 1 megabyte, 1.5 megabytes, 2 megabytes up, down, and about 0.37 megs up. So I'm going to jump over into NS1, and very quickly what I'm going to ultimately do is I'm going to create a CNAME for this guy. So yeah, let's do create new record, and we're just going to call him NFD speed test for short. It's going to be an A record, and then he's going to go to that same IP. And I'm going to also, just for fun, I'm going to make a duplicate record of this guy, and I'm going to call him LB-NFD-speed test. It takes on average maybe 1 to 3 minutes for initial configuration, and that's why if we have a customer, when they come and call us and they say we have users expected from California, blah, 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 or wherever we have the initial user base coming in from, that's why we ask that question. If we didn't have that question, what would normally happen is because we're able to get the actual true client IP and where that client's coming in from based on their GeoDNS, we're able to determine this is where a new user base is coming up from, and that's how we're able to, on demand, spin up these new TCRs for regional support.
So how much of this is client operations? How much of this is your setup? It's all of this if I was a customer, is all this what I would do in order to set this up?
So this is all internal. So this is what we do to have the first creation of the VBN. So Teridion as itself is a SaaS-based solution. Customers just say this is a site that we want optimized, and we go through and create this. On the roadmap, there is more of a self-sign-up type model that would potentially come into play. But as of right now, any type of VBN creation is done internally through this UI.
Okay.
Yep.
Well, what? I guess I missed that. I assumed that the customer was going to be doing this. In which case, my question was, is there an API? Because that took a little too many steps for my liking. If you guys want to do that, feel free. My question then becomes, what then would I use the portal for?
So the portal for is also not just for VBN creation internally, it's also used for data, looking up and seeing what the actual traffic patterns are, and customers can do this to actually see where they have high traffic, what their actual improvement has been through the Teridion portal. I do have another step of the presentation that I'm going to go over an example report that's available to a customer.
Okay.
So if there's any more questions with that, happy to answer that when I have that up.
Okay.
Okay.
So you installed the TCR on the endpoint, like you installed it on the web server?
So what I did in this point is I just said I have basically where I want to have my TCRs installed. I said I want to have a TCR in, or where my user bases are going to be coming from, in San Francisco, California, and I also want to have who reports to the TCR out in Bangalore, India. So what I basically did right there is I told them that I need these 2 TCRs deployed, and I need a tunnel to create them. I also need to be able to tell it that all traffic that's supposed to hit this TCR out needs to go wherever that target domain is, which is my speed test server load balance domain.
And you're just using a DNS redirect to redirect the regular requests. Instead of going direct, they're going through Teridion.
Yep, and that's the next step. So this is something that the customer would actually do on their side. That's a question?
You just set up 2 TCRs
Correct.
for this test?
Yep.
So how they will reroute in case of congestion on the tunnel? You need to spin up a third one to reroute it?
I personally do not. So once a network is created, then it knows that, okay, I need to go from this general geographical region to this TCR out. And then if there's ever any problems within this geo region that this TCR in is no longer optimal, it will move it to a similar cloud provider in that region as well, or a better performing one. And then if there's a reason why the tunnel in between the two, doing normal routing, is having problems, it will spin up an additional TCR and kind of start a relay race, saying as opposed to trying to do the direct hop from my SFO TCR to my TCR out in Bangalore, it'll say direct it to Tokyo first and then go to Bangalore or something along those lines.
So the minimum you need 2 TCRs.
The minimum is you need 2 TCRs right now, correct.
It's been on my mind the whole time. So if you're a customer of like a cloud proxy provider like a Zscaler, I'm still trying to figure out how I would be able to use this type of solution with a cloud proxy provider. Have y'all had any use cases like that? I don't think I could use this service if I'm already on a cloud proxy.
So now if I actually go to the guy that I pinged, should hopefully see the difference. Yep.
Big in it.
This is why they employ people like me who know how to use somewhat of DNS and somewhat of UIs. So we went from a 2.16 download and 0.38 upload up to a about 30 megabytes up or down and 4-5 megabytes up. So from this perspective, again, this is basically what we need to do in order to set up the network. What we can also showcase is just some of the actual catch point results that we consistently do for customers. So what we're looking at here is just a standard catch point graph. If you're not familiar with catch point, basically what it allows me to do is set up remote nodes from around the world and test downloads or test web page response times. What we have set up here is what we've done is what we call an S3 rewrite. S3, Amazon has their own S3 accelerator. They all claim that they have this ability to make your uploads 2 to 5x faster. So let's take a look at what Teridion can do with a similar type of idea of just making the packets go faster.
So I have another follow-up question.
Yep.
Do you find that there are situations that you'll get zero optimization? And what percentage of the time are you able to significantly optimize versus not so significantly? These are probably best case, I'd have to assume, scenarios.
Yeah, so again, just like the internet, farther the geo region, the better the optimization is going to happen. I would say, though, there's even been scenarios where, for example, I run a local speed test to a speed test server within San Francisco. I might get better to the India speed test over Teridion as well. So the one thing that's not just necessarily we're going to improve the internet, that 20x faster number is what we like to throw out there, it's also the consistency. So it's not necessarily just that you're going to say we're going to improve the speed 20x faster. It's also whatever your speed you're getting at 8 p.m. during that time frame is also going to be the speed you're getting at 8 a.m. or whatever peak hours you're going to have during the business day.
Another, if I may answer for this, there are use cases where you will not see the improvement, or you will see a little bit of improvement, maybe sometimes even negative one. For example, one of the things is if you have a monitoring system like New Relic or Pingdom of all those, and you try to compare with and without Teridion from those types of services, you might see very little, if any, improvement. The reason for this is that all those monitoring services they have their own POPs, and they usually rent their own fiber, between all the Equinix data centers. So if you try to measure it from, New Relic, for example, then New Relic forces it to go through their fiber. And if you try to do this with Teridion, you're actually pulling it away. Remember the black hole kind of thing? You're pulling it away from there, and then you're routing it through Teridion. Now, it might be the same, but then somebody had to pay a lot of millions of dollars to create this fiber from here to here. Teridion cost nothing, literally. And so in these cases, sometimes we have customers who say, hey, we don't see much improvement. And then we tell them, why don't you measure it from like another tool that actually, Catchpoint, for example, allows you to have tools from a lot of people PCs around the world and actually test the end user all the way from the last mile all the way to them. So the Zajac and all sorts of things. So these are some of the use cases where you might not see a big improvement on Teridion. If you have your own fiber, then obviously that's a whole other thing. Having said that, the demo that we started with, the upload, it was a server on Amazon server to another Amazon location, S3. Amazon has their own fiber. However, what this showed you that in some cases, actually what we did is we pulled it out of Amazon, used Teridion, and then put it back on Amazon. And even in the in the continental US, West Coast to East Coast, it was 24 times faster. And so there are cases where it doesn't work because some people force route. Then obviously this doesn't apply for them.
So is there instances where you're using provider exchange networks in order to provide that acceleration?
We are always using when we deploy a server on DigitalOcean has peering and all that stuff. But what's unique for Teridion is we know how well these peers are working. The routing right now says if traffic comes here, we have a peering that between 7 a.m. to 9 a.m. go to level 3 because that's the cheapest one. Everything goes there. We know that right now Cogent is actually faster. So we force it to go through Cogent and not to level 3. So we always use them. But we know how to use them better than, most likely better than they know. And Bill will actually show you how, for example, on Amazon, how Amazon uses.
And do you show, is there a way in your interface to show the path optimization or show the path difference between a regular path and the Teridion path?
You see the difference in performance. We do not disclose it. It's our proprietary information. It's pixie dust.
So one of these tests that we've ran within Catchpoint as well is this standard S3 download that we have with this file. So from just a visualization perspective, blue is just an S3 download from California to an Australian-based S3 bucket over regular internet. Green's the same test, but leveraging Teridion. Red is just going over to US S3 bucket, same California-based test client over regular internet. Then purple is just over Teridion as well. So what we ultimately see consistently is this is for last 24 hours for this test. We see Teridion is substantially more faster than the regular internet in terms of not overall response time, web page response time, and we're also 100% available as well. S3 again is going to be 100% available, but when you're sending your traffic through another network, one of the concerns is, well, how consistently can you provide this traffic? Well, as opposed to looking at in a bar chart form, I'm going to switch this over to a heat map. And I'm going to showcase just what those numbers look like. Again, green and purple are over Teridion, and then blue and red are over regular internet. And I'm just going to put this in for the last 30 days, just to see how it looks from this guy. Go ahead and just going to launch this report again. He's going to turn a little bit, and then we'll zoom in, and we'll see what this ultimately looks like. And surprisingly, we do have some failures. But if I do take a look at what the actual failures are, most likely they're going to be over direct connections from within this link as well. So again, these two lines that are almost blurred together from the purple and green, whoops, I just opened up a new page, are going to be the Teridion numbers, and then we see the consistency that we're providing across the board. We also see that, again, just using public internet, S3 is very consistent, it's just less consistent than what Teridion's providing. Jump back over to the PowerPoint real quick. So there's been a lot of talk around how there's this logical engine that's able to make these decisions dynamically and how it actually works in the back end. So primarily we have two different data sources that we're pulling in from making these decisions. One's a Neo4j based database that I'm going to run a couple queries and show you what that looks like in real time. And then of course we have Kibana on top of Elasticsearch. What we're using the Neo4j database is just to see the consistencies and long-term strategies of how the internet works, where the actual points are that we should be connecting, and then if there's any additional need to change routes at this specific moment, that's what we're using the Kibana and Elasticsearch engine for. So it makes a lot of sense that we have these TMAs reporting into two separate areas where we have more of a long-term historical database of what the internet has always done, and then we have more of a real-time picture of if there's anything that we need to act on at that specific moment or change routes at that specific moment as well. From the Neo4j database, what I can visualize is a couple of different ways that our actual routes are looking. And I'm going to pull up a similar speed test query. that basically showcases me how far and how diverse this path actually looks. So for example, we have this individual speed test, again, India speed test, very similar to what we use for a lot of our demos. He's associated with some sort of customer or client. In this case, it's our internal sales. And this will show us what are all the different regions that we're supporting and where we're actually being able to pull in information from for each one of these speed tests that might happen with customers. And then each one of these individual sub-regions, I can expand to see where is he actually currently deployed, what is the ultimate domain that he's going to, as well as what is the cloud provider that he currently has access to or he currently has TCRs deployed. And if I go one step further, I'm going to see where the actual guys and all the other peers and all the other TMAs and everything else that he's getting his information for in order to get this, this VBN actually spun up.
When people join Teridion, we ask them to learn this map by heart, and then we test them on it.
Right. What happens when it breaks? What happens when something happens? We're on the cloud, so there's going to be issues with just a VM on a cloud service going down, being inconsistent, having to move things around. So ultimately, within our organization or within our architecture, everything is high available. What that means is each TCR that we spin up also has a counterpart auxiliary TCR spun up. That's also doing the same exact region, or it might be in the same cloud provider, might be in a different cloud provider, as well as the TCR outs on the other end. So let's say there's something like a TCR has a fail. When there's a problem, what's nice about this is when the TCR in, let's say, fails, immediately NS1 is able to detect that it's no longer responding to us, we can go to that auxiliary without impacting customers. Let's say there's a TCR out that fails. Again, since there's an auxiliary, that TCR in will automatically know that as opposed to pointing directly to my primary, I'm going to fail over to my auxiliary, and then traffic will be spun up as normal. As soon as that failure is notified, it also is able to get sent over to the TMS, and then a new TCR out is spun up, and then we can start managing traffic that way.
What mechanism are you using for that failover? Is it actually moving the IP address from one to the other? Or?
So in the case of a TCR in failing, it's just a DNS change that we're acting on through NS1. And then in the case of a TCR out failure, it's actually we're telling the TCR in to point to his auxiliary. And what actually happens in real time is as soon as the TCR in realizes that his TCR out is no longer responding, he will automatically fail over to the auxiliary and then notify the TMS that there's something going on with this TCR out.
Do you spin out a TCR for customer, or you share it for multiple customers?
Every VBN, so every customer is going to have their own TCRs. We're automatically going to have a failover TCR in that's already waiting there to accept traffic in a nearby data center. Okay?
What about Hurricane Sandy?
So if Hurricane Sandy in a complete region goes dark, and if our customers are hosted out of that data center, well, then their application's down. But if it's something like we're leveraging that cloud provider or region in order to route traffic through, then because of the failover and because we would notice that the route's unavailable, we could spin up TCR ins or TCR middles or anything like that in a different geo region to route around Hurricane Sandy.
Okay.
How do you deal with, so each of the cloud providers, I would expect, would be honed to multiple service providers for their infrastructure, and they're going to be advertising their routes out multiple directions. I understand that you can go hop to hop, but even so, how do you force traffic to go through the provider route you want, rather than the magic of the internet taking it the way it still wants to get there?
And that's where the middle hops normally come into play. So ultimately, if we do need to have a specific provider that we want routed through, well, we need to figure out how can we leverage that provider to the next hop. So for example, if we have a East Coast-based TCR in and a West Coast-based TCR out, and most of the traffic flowing out of our cloud providers is going down a path that we don't want to route, we have to find out where is there a cloud provider that we can point maybe north of him or south of him to force the traffic down the actual the provider that we want to utilize as well.
But even from your like into your middle, you're still at the mercy of the internet. You're
still at the mercy of the internet, correct.
Somewhere else to drag the path around it, basically.
And within that provider, you're still at the mercy of that provider, so you're almost looking for where's the quickest place I can get the heck out of that provider.
Yeah, and if there ever is a problem with the provider where he is just not able to perform for that local geo region, we'll just move to a different provider that's local as well. The good thing about cloud providers is they normally stand up next to internet exchange points, so there's normally some other one that we can move to pretty easily without going too far from a geographical perspective.
But isn't that exit point kind of defined by the metrics that you're gathering with the TMAs? I think those were. I mean,
So, yeah.
This preferred route issue coming out of a particular provider, the fastest route is coming from your metrics. You're defining that by measuring what the performance is going through that local area.
Yeah, and so the question is, when we have a TCR deployed in a specific cloud provider, and we know that that cloud provider has multiple outs, obviously, multiple peering relationships, how can we force it down a singular peering relationship that we see is the best one? So that's where our shortest path algorithm really comes into play, is if there's a way that we can make sure that we can have a TCR in that cloud provider, and then at the next hop, make sure that all traffic going in that direction is going to that subsequent TCR in, or TCR middle, then we'd be able to actually make sure that we're getting traffic routed the right way.
So a good example for this might be if you think about courier services. So let's say I have a package here in San Francisco and I want to send it to New York, and I'm sending over the regular internet. I have no control over it. But let's say I want to force this package, regular UPS package, or I want to force it to go through Houston, Texas. I can take this package and put this box in another box that's addressed for somebody in Houston. Then it's being sent to Houston. I ask my friend over there, open the box and resend it in UPS. And now the box inside says New York. And now I forced it to go to New York. Now, if you do this, actually repackaging the packets, if Teridion would have done this, it will create latency, and there will be a lot of frame issues and all sorts of stuff. But that's the general idea behind it. So that's how we can force the packets. It's not like, we don't do this exactly, but that's the idea behind it.
You also provide 7x24 tech support for such customers, or they don't need it, or?
We're also in the US and in Israel, so we actually provide 8x25.
8x20.
Yeah, so it's 724.
So just recapping again, if the TCR ins go down, there's normally a subsequent auxiliary TCR in that you can automatically direct via DNS. If a TCR out goes down, then it also has an auxiliary TCR out that it can start directing traffic to. If by some miracle the internet, like Hurricane Sandy, comes and wipes out the complete western seaboard, and both TCR ins go down, worst case scenario, we fail over to public internet. Obviously, in that case, they're not on our network. They're getting routed through normal routes, but it's something that we have to prepare for just from a high availability perspective, as well as very similarly, if both TCR outs go down, we also have the mechanism to go direct to origin in that case.
Well, I got to think for acts of God like that, right? You're going to have at least this isn't true for all types of disasters, obviously, but for Hurricane Sandy, for instance, in theory, you could spin up more TCRs ahead of time and maybe sort of do the failover yourself. Obviously, it wouldn't be as optimized as this model would be because you're not putting them where you want them, because where you want them is in the hurricane.
Yep.
But you could ahead of time say, yeah, I'm going to put it up in some remote place like Canada, something that doesn't matter, and have it up there. It's something that you could probably do ahead of time, I would imagine.
Yeah, I mean, I'd have to see what the algorithm would actually say about it. But yeah, you're exactly right. If there was ways that we could say, well, the best performing way to get from the eye of the hurricane over would be through Canada. I mean, we definitely could do that. So
yeah,
okay. This is what a lot used to look like before all of his talks. So
Who is this guy?
So you had mentioned your your shortest path algorithm. Is that built off of a common protocol out there, or is it completely proprietary?
It's all completely proprietary. Yep. Because it's quickest path, not necessarily shortest path. So.
Or best path, maybe. So the actual answer for this is that when I started the company, I said, well, I don't want to build anything that is already there. So, for example, when we started this, we actually took Open Daylight. I don't know if you're familiar. It's a Teridion. So let's use Open Daylight. I mean, it's an awesome toolkit, right? It doesn't scale to the size we want. It doesn't do a lot of the agility and all that stuff. So we had to write it our own. And then we said, let's use an SPF, some sort of an algorithm. They're out there. Everybody's using them.
Right.
And we try to apply it to our matrix, and it's just much more complicated. There's a lot of heuristics and a lot of stuff that we need to do, and things that change so fast that just all those things didn't work out well for us. So we had to go ahead and figure out how we want to do this. And so we also have the IP for all those things.
And there were questions on Twitter around target markets. I think some of you started putting on your end user hat. How do I use this? How do I use this? How do I use this? Our target customers are very broadly defined SaaS companies. If you define a SaaS company to include, a Salesforce.com, a DocuSign, Box, who is a customer, Ignite, who is a customer, voice and video, online gaming, ad networks, over-the-top TV, anyone like that. Anyone who's got basically a destination application or a destination URL at a data center and then try to speed traffic from around the world to that one destination. You were asking questions about SD-WAN earlier. I spent 5 years at Riverbed in my past. SD-WAN and WAN-op is very point-to-point. It's branch office to headquarters. We're kind of from a data center to anywhere, and we're targeting the data center providers or the cloud providers like Box or like Ignite, who pay us to speed traffic for all of their end customers.
The reason I was saying is that there's something missing in the SD-WAN, I see that this fills the gap. What SD-WAN cannot do is to traffic engineer the path over the internet. So this is something, I see that this solution can fill the gap, but you're not targeting some of the customers what the SD-WAN customers are targeted. So that was my,
Yeah, we're not selling to enterprises. We're not competing with SD-WAN. However, we could collaborate with SD-WAN because a lot of people are running SD-WAN over MPLS links.
Yeah.
And they're paying for MPLS links to try to get the kind of reliability. With our consistency we provide and our performance we provide, you could instead run your SD-WAN over public internet using Teridion.
Correct.
So we could work in that layer. We've had some discussions in that layer, but really, I'm head of worldwide sales, and my role thing is focus, focus, focus. And so we're focusing on where we have the best traction, the best use cases is around file sharing and sync, SaaS, cloud backup and storage, real-time voice and video, online gaming, ad networks, these people. Then we're looking kind of opportunistically at where else can we start to play. You asked about telcos, you asked about SD-WAN. Yeah. Those are all opportunistic. We brought the product out in GA about 9 months ago. And we're really focusing on where we have the most critical use cases. And if you think about it, the questions in the background, reliability and failover and pre-planning for a Sandy, there are some services that will work without Teridion. They just work better with Teridion, like file sharing. And there are some services or use cases that won't work without Teridion, like maybe online gaming from here to Europe. Xbox Live won't let you connect with a player in Europe because they say the network's not good enough. If Teridion gets in the middle, the network's good enough, we can enable that use case. So there's both things that we make better and things that we make work altogether that don't work.